Today we're going to talk about the one of the simplest quadratic function, which is f of x equals x squared, which is right here. We're going to begin by introducing the concept of a function. Here's the definition of function. A function is a rule that assigns to each element, everyone, in a set of A. So there's a collection of elements in the set of A, exactly one element called f of x in the set of B. What this means is that a function is a rule. So this rule is going to spell out. And following this rule, this function will take input. We can call it x as input. So this input is going to be given to the rule for the rule to apply to it. So the rule applies to the input and then produces an output. And this, how many output it can produce? For each input, it can only produce exactly one output, exactly one element. And all of these output will be in B. So there are two sets, one set A, which is the input, and there's another set of B, which is the output. And A, okay, usually is a collection of all possible inputs. We call it domain. And B is all possible output by applying the rule of the function to all possible input in the domain. Okay, so domain means include every possible number that the rule can apply and produce exactly one output. Exactly one output is a very critical requirement, okay? Not less than one, not more than one, but exactly one. All right, so let's look at the example of f of x equals x squared. And obviously this is a rule. And here we're gonna talk about the notation, okay? There's a different notations here. One of the notation is that we're mostly probably familiar with is y, okay? Y equals to x squared. So what it means is that this rule is we take the input x and we multiply itself, it produces an output. And this output can be called y. It can also be called f of x. F of x is another popular notation that mathematicians like to use. In this notation alone, we indicate the input in the parentheses and the rule, which is f, shorthand notation f, which is function. It basically says, okay, the rule applied to the input and that rule is x times x, okay? If we draw a figure similar to the rule of function that we drew above, is that we will, from a set of A, we have the input, and the input will be, will be sent to be applied the rule, and that rule is going to be x times itself. So the input times itself produces the output. Okay, so that's the meaning of notation. So in most situations, we can use y, we can use f of x. The difference between these two notations and which latter might be preferred is that this indicates both the input and output in one notation. And this is just spelling out the rule and the output, okay? So now when we think of all the possible numbers, this rule can be applied to, which is a number time itself, and that is all real numbers. Therefore, the domain for f of x is all real numbers. Consequentially, by applying this rule to all real numbers, any number time itself is always going to be positive or zero, which is all non-negative numbers, right? So the range will be positive number or zero. So you can say it's all non-negative numbers, but it would be wrong if you say all positive numbers, because if you say all positive numbers, it would have excluded 0. 0 is not a positive. Okay, so the domain for f of x is all real numbers, and the range would be all non-negative numbers. The interval notation, okay, there's an interval notation. The interval notation would be from 0 with a bracket to positive infinity. The positive sign is optional, of course, and you don't have to have it, but you could have it. That's not a problem. Okay, now let's look at the graph. So this rule of a function will produce a graph for us. And here we're going to apply the rule to -2. I'm just selecting a couple of input here. Okay, the number I've chosen, the input is -2. Then applying the rule, so -2 squared, -2 times -2. -2 times -2 is +4. So by putting input output together, so input comma output, this is called an ordered pair. That will be input comma output. For -1 input, the output will be produced by applying the rule, -1 squared, which is -1 times -1, which is a +1. So when input is -1, the output is -2. So see, they're always in the same order. Input is the first number, output is the second number. And you can also say x comma y. Okay, so input is x, and x, and output is y. Okay, and input x, output y. All right, so this is the ordered pair. For 0 input, the output is 0. For 1 input, output is 1, and we produces the points accordingly. Okay, so we get input, output, input, output, input, output. Could I have chosen fractions, decimals? Of course I can. I can choose many points. Okay, but for simplicity and for sketching the graph, we can just choose several points. We chosen 5 points here. If we put them in the order, in a table form, right? So you put all the input together, all the output following the rules, which is commonly done by textbook, right? And input x, output f of x, which is x squared here. And we got all of these points. And we're going to put these points in the graph, in the rectangular system. So for input a -1, 2, output is 4. So input, output, right? So let's understand what this means. -2 is the input, and the output is +4. Input, output. So the input is a horizontal measurement from the origin. The output is a vertical measurement from the origin. So from the same point of reference, but one is horizontal, the other one is vertical. And all the other points are being done the same way. So that's how we get those points. That's how we read the chart. Okay, so all the points are in place. All the points are in place. -2, 4, -1, +1, this point, 0, 0, 1, 1, 2, input, output, 4. And when we connect these dots, guess what happens? Let's connect these dots. When we connect these dots, we're going to get the graph. We get the graph. So this is the graph for f of x equals to x squared. It is also called a parabola. And this graph also reflected the domain and range. Okay, you can imagine the curve extend from both directions infinitely. In this direction, the input could keep going. So the curve will keep going up. Okay. And in this direction, the input will go as far as possible horizontally, and the output will keep going up. The curve is keep going up. So this is the curve. And this curve reflected that the input is any real number, the output is all non-negative numbers. So greater than 0 or equal to 0. Okay, so you can see all of these output. Okay, the lowest one is 0, and all of these output, see, they're positive. They're above x-axis. They're above x-axis. Okay, and that's what it means that the output is greater than 0 or equal to 0, and the lowest point is 0. So when you read these numbers, the first number is the input, which is the horizontal measurement from the origin, and the second number is the output, which is the vertical measurement. So the output are going to be, for each input, there's a respective unique output. So this is the basic parabola. We call it, this is the simplest quadratic functions there is. All right, so now let's look at another function. Okay, so we got, f of x equals x squared. And next, we're going to look at the other function, g of x equals to negative x squared. Okay, negative x squared. How does this do? Well, if you look at from the function's perspective, the input is x, and we apply the rule, which is x times x, we produces x squared. And then we apply the negative sign. We make opposite of the output from x squared, which we put a negative sign. So negative x squared. Be careful, okay? We do the x squared first, and then the negative sign. So when we plot the point, suppose we still choose the same input, -2, -1, 0, 1, 2, right? So we've done for f of x equals x squared, and we got the output. Input, output, we got those points. For this new rule, okay, we view g of x equals to negative x squared as a new rule. Okay, this new rule basically put a negative sign in front of the square. So for -2, we have a negative sign and of -2 squared, and this has a parentheses. And so there's a negative sign, we have a -2 times -2. That equals to -4. So for input a -2, we get -4. The output is -4 for this new rule, So for -1, it is negative of a -1 times -1. It's a -1. So for input -1 and output is -1. Okay, and all the others are calculated accordingly. Okay, be very careful that we meant that these three operations are different. Okay, so here we want to show you the difference. So -2 squared is a -2 times -2. If we don't have the parentheses, it's a -2 squared. It's being regarded as the base is 2, and the base is a -2 here. Okay, this is the base, which is -2. In this case, the base is 2. So we, by order of operation, we will do -2 times -2. In this case, however, we're going to do 2 times 2. That's what 2 squared is for, and the negative sign is here. So that's a -4. In the case of negative or -2 squared, right, like what we did here, and -2 again is the base. So -2 times -2, that's going to be equals -4. All right, so now let's put the points in the graph. Okay, let's put the points in the graph. So what I'm going to do is that I'm going to put the points. I'm going to show you the points in the graph right here. When input is -2, the output is -4. Okay, for x squared, when input was -2, the output is +4. So see, one is if for the same input -2, for the same input -2, these two rules will give out a different output. So one is a +4, the other one is -4. The same is for -1 input. For the x squared, for -x squared, we're going to have a -1. So that we get these other point. Okay, same input, different output. So this is going to be true for every point, every input we have chosen. Of 0, stay where it is. Okay, stays there. For 1, for x squared is the output is 1. For -x squared, the output is -1. So here we get have 1, -1. And for 2, with x squared, we have 4. For -x squared, we get -4. So we're going to get the other point. So when we connect these dots, these red dots, and we got a -x squared. Okay, so here we're going to summarize what we have done here, right? So over here, this graph, on this graph, this will be the graph for x squared. And this will be the graph for -x squared. Okay, of course it's marked here. Okay, it's marked here. Okay, and next we're gonna see some other functions. Okay, next we're gonna see some other functions. I think we're gonna do another clip. Okay, so that's all for this clip. See you soon.